Hi, Rainey, and anybody else who might be listening at home, just for the sake of going over the lesson again. Look up here, please. Notice sounds. Couple things to note, no pun intended. From yesterday, we were running an experiment for measuring tides at a hypothetical Pebble Beach. May 17th, 2021, which creepily enough was yesterday. At 12 midnight, we started the measurements. What was the first event that was measured? So, yeah. First low tide. Give me the data for that. There are two things, the time of day and how high it was.
3:15 a.m.
Okay.
And it was at 2.68 feet.
2.68?
Yes.
Okay, 2.68 feet. Okay. What else? There was one other event that we measured. Anybody have it? Yeah. The first high tide. Just a second. Okay. What time of day?
It was at
1:45 p.m. And what height?
6.88 feet.
Oops. 6.88 feet. All right. We got a little bit into this problem. The first thing, did we ask a question about this or no? I think I might have been saving that for today. With a problem like this, usually they set you up with this information and then they say, find the equation of the time height. The very first thing I would suggest doing, and if you haven't done it already, is graph. Make a long graph that goes way to the right and quite a bit up. Why is my graph so lopsided? Yeah. Yeah, there's no such thing as a negative height. I mean, you can go below sea level some places, but not on Pebble Beach. And you can't go back in time without, take it up with Einstein if you disagree. So, and with all due respect, it's Back to the Future, blah, 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 blah. So, when at this point, X is the number of hours since the start. And in this case, the start is 12 midnight on May 17th. Okay, so that's here. X equals 0, there's your starting point. The very first event occurred at 3:15 a.m. And the second occurred further along the day at 1:45 p.m. I'm kind of guessing how far to go. It doesn't have to be completely insanely precise. But I think we got this far yesterday. We got the top, the high tide is 6.88 feet. The low tide, I'm just going to mark it. And I'm guessing as to how high it is. Of 2.68 feet. Is it everywhere so far? I think that's what we had yesterday. Yeah. I'm sorry? Wait, the baseline. How do you find the baseline? Refresh my memory. Divide by 2. In other words, you find the what? Average. Correct. So to get the baseline, so this is the max. This is the min. This is the baseline. The baseline is found with 6.88 plus 2.68 divided by 2. What do we get there? Should we have it written down? Good. 4.1, I'm sorry? 7, 8? Nice. So be with me so far. If you had this data, could you construct this graph so far? Now, what was happening at 3:15 a.m.? Nick, what event happened then? Low tide. So how do I indicate that on the graph? Yeah. So what do I put there? A dot. Exactly. I put a dot at 3:15 a.m. at 2.68 feet. And ditto for 1:45, the high tide. Now something important. This says it's the first low tide of the day. And then the first high tide of the day. Well, first high tide ever in the experiment. That means, every look at watch, look where I'm pointing. See if this is true. Could it go like this? Up, down, up, down, up, down, up? No, why not?
Because it went up, the high tide was,
The high tide was what?
that one has to be the first.
Right, this has to be the first high tide ever. If I had gone up, down, up, down, up, there's like 3 or 4 high tides before the first one, which doesn't make any sense. Does that make sense? So, that came out a little wrong. But the only way you can make this work is if it slowly swoops up. And what's going to happen after that is it slowly swoops down. Eventually, it's going to hit the low tide again, the minimum. This is starting to look like a sine or cosine graph. If it is a sine or cosine graph, we should be able to find some measurements. First thing, I need the baseline, which luckily we have. Can somebody give me the equation? This one, yeah.
Is it y equals 4.78?
Y equals 4.78, exactly. What do you find after the baseline when you play with these things, Josh? Amplitude. Any idea how to get that? Right. Subtract these two. Or if you want, you can subtract these two, whichever you want. What do you get? 2.10, 2.10, 2.10. Correct. You've just found the amplitude. Everybody see how I did that? So 6.88 minus 4.78. In other words, a higher one minus the one right below it. Because the amplitude is from the baseline to the max or from the baseline to the min. So take your pick. They're both the same. Can somebody find the period for me? This is a little on the tricky side. In order to do this, you have to convert these to number of hours. This is a time of day. This is like the difference between humans and computers. If you plug this into a computer, it can graph it for you, but computers have no sense of time. They don't, at 3:15 a.m., oh my goodness, I overslept 15 minutes. No. It's just, they keep track of the number of hours. The 3:15 a.m., where you count by 60 minutes in an hour, that's a human invention. We didn't have to have it. We could have had 100 minutes in an hour if we wanted. Yeah. You do, although it depends on where we start. And I don't know where we're starting at. Absolutely. In order to start this thing, we need horizontal shift. But that's kind of a mystery right now. My question is, how many hours is this? Yeah.
It's 3 hours and 15 minutes.
Right, 3 hours and 15 minutes. What about in total hours? 15 minutes is how much of an hour? Yeah. A fourth of an hour. What's that in decimal form?
3.25.
There you go. X equals 3. It's 3 plus 15 out of 60 if you want to be technical. You have any idea why I did 60? Yeah. Yeah, 60 minutes an hour. So I want to know how many total hours. It's 3 whole hours plus a piece of an hour. This is 1/4. So 3.25. So as far as the computer is concerned, the first event happened at 3.25 hours. The computer does not think in terms of hours and minutes. What about this one? Can somebody convert that to hours? It's a little trickier because it's PM. But it's kind of the same thing. Yeah. Okay. I'm sorry? Maybe. 1:45 p.m. Ah, very good. Where do you get the 13 from? Right, because this is PM, so it's in the afternoon, which means you had 12, like you have to cover the morning, then another hour, then another 3/4 of an hour. What am I doing? 3/4 of an hour. So if you put the whole thing together, it was what again? Sorry? And then 3/4 is what's decimal. Right. 13.75 hours. That's a key step in doing these problems. Again, you're basically talking to a computer or a calculator, which is a small computer. They do not think in terms of hours and minutes. That's humans. The calculator just wants to say, what is x? X is the number of hours. Give me a decimal or a fraction. The decimals are relatively nice, so I left them as decimals. If this were an Icky fraction, like 17 over 60 or something like that, I would just leave it as a fraction. But for right now, the decimals are decent. So the first event, low tide at 3.25 hours, then the high tide at 13.75 hours. Question. What length of time is this? How long was that? How do you find out? Yeah.
You subtract 3.25 from 13.75.
Yeah, subtract. So 13, I'll just write it. 13.75 minus 3.25, what do you get?
10.5.
10.5 hours. Did we see that? So that interval between the low tide and high tide was 10.5 hours. Question. Courtney, is that a full period? From here to here? No. How much of a period is it? Half. Let me put this over here. 1/2 of a period looks like it's 10.5 hours. How do you find a full period? Times it by 2. You double it. Just make sure you do it to both sides. What do you get? 21. The period is 21. That is a relief, because we needed that for the graph. Have you read this part? Now we need to decide, what kind of a graph is this? Is it cosine or is it sine? Yeah. Sorry, can't see me grin behind the mask. You're right, partially. It's both. It completely depends where you start. What if I start here? What kind of a graph is it? Kelly?
Negative cosine.
If I start here, it's a negative cosine, yes. What if I started here? I have no idea how far over it is, but what if I did start there? Megan, what kind of a graph would it be? Yeah, it starts at the baseline and goes up, so that'd be a positive sine graph. What if I had started here? Becca? Right, it would be a positive cosine equation. And again, I don't know where this is, but what if I started here? Well, negative sine. And what about if I started here? Just Spencer. What kind of a graph would it be if I started here? Negative cosine. Does this make sense? So it's a sine or a cosine graph. Now, could we find these starting points for sine and negative sine? Yes. There are two things you can do there. Since this is a smooth curve that's predictable, it goes the same distance every single time, I can pretty much guarantee you this will be exactly in the center. So if you go halfway between 3.25 and 13.75, you'll find that. How would you do that, by the way, if you want? I'm not going to do it, but if you wanted to. How would you find, yeah?
You add them together and divide them by 2.
Right, average them. 3.25 plus 13.75 divided by 2. That's actually not a bad number. It's 17 over 2 or something like that. Whatever. But you can find that if you want. When you're running an experiment like this, last chapter test, you might remember, I had you find 4 equations, positive sine, negative sine, positive cosine, negative cosine. That was for practice. If you're hired to do something like this, you do not need to get all 4 equations, because all 4 equations should give you the exact same answers all the time. That's the reason, you know those 4 that I had you do on the test? You could plug x into any one of those 4 and it'll give you the exact same answer all 4 times. What does that mean for us? It means that we can pick whichever equation we want that's easy and just use it. So if you like positive sine, go ahead and do a little extra work and find the starting point. But as long as, do you notice we already have two starting points? What kind of equations could we do right away without any extra work? Please. Which two starting points do we actually have?
The negative cosine, positive cosine.
Right, we have a negative cosine start right here. And we have a positive cosine start right here. Can you find other ones? Sure. But you've got these without any extra work. Your job? Pick one that you think is next. I will anoint Abby for this. Which equation would you like? What kind of a starting point would you want? That you think would be easy? Positive cosine sounds good. Okay, we're going to do positive cosine graph. If I choose this positive cosine graph, can you tell me the horizontal shift now? Now that we have a starting point, we should be able to find it. And don't work too hard, it's actually pretty easy.
Just 145.
That's in human terms. How about in computer terms?
13.7.
Exactly. 13.75. We now have all the pieces we need for our equation. It's going to be y equals a times cosine, parentheses b, parentheses x minus h, paren plus k. I'd like somebody to reconstruct that equation. Ooh, excellent. Good thing. Mary Claire. What's a? I'm sorry, second? It's the amplitude, which is what? In this case? Yeah, it's 2.10. Let's do it, gentlemen. Y equals 2.10. Was that positive 2.10 or negative 2.10? Positive, yeah. Because it's a positive cosine. Use positive 2.10. And then what? Cosine. One more question for you, then I'll bounce to somebody else. How do you find B? There's a formula for it. Okay, actually the backwards one. How do you find period? What's the normal period? Okay, so like one complete cycle is like once around the circle. 2 pi. So the normal period is 2 pi divided by what? One of these letters. B. Nice. So B is kind of the backwards version. If P is 2 pi over B, then B is 2 pi over P. So go ahead and jot that down if you need to. And go ahead and use that. Do we have the period up here somewhere? 21. This is B. 2 pi over 21. And just leave it. It's an interesting looking B, but okay. X minus what? Sam, take over.
Minus 13.75.
Yeah, your starting point, your horizontal shift. X minus 13.75. Paren plus what?
4.7
Yeah, where'd you get that from?
baseline.
The baseline, 4.78. Congratulations, you have an equation that if you give it the number of hours, it should give you the height of the tide. Anytime at all. That's going to be one of the test questions. Now, let's use it. Take out your calculators. If you don't have one, grab one off the table. You will need to be familiar with how to use these. I think a bunch of these already get used, which is totally fine. Make sure I have 7 when I'm done. There are 2 more over here if you want to grab one. So let's see if we can reconstruct this thing. One question I'm going to ask is, go ahead and write this down. What's the height of the tide and I would like 4 decimal places. What's the height of the tide at 8:45 p.m. May 17th, 2021. No, it's the same day, but at 8:45 p.m. What's the height of the tide? Anybody tell me where to start with that? Like, you have the materials necessary to answer that question, but you know, how do you do that? Brainstorm. Any ideas? Yeah.
Picture, 8:45 p.m. into a decimal.
Yeah, I want to get this in the number of hours. X equals what? Like, how many hours is that? Talk me through it.
Be, since p.m. is 12,
Yeah, PM gives you 12 plus what?
8,
Another 8 plus
3/4,
3/4. What is that as a decimal?
0.75.
Good, 0.75. So 45 minutes is 7, does it make 0.75 of an hour? So, okay. So what is that total?
20.75.
20.75. Any idea what to do with that?
You put it into the equation.
In place of what?
X.
Now let's see if you can type it in. This is actually a little bit of a battle. The parentheses are important. You should, with a typical calculator, be able to type this in without extra parentheses. The order of operations does require the parentheses be around here and around here. So it should be double parentheses when you close here. Try it. Oh, yes, double check. Everybody's calculator probably is already. Actually, no, it probably isn't. Stop what you're doing for a second before you type. Does anybody have a key on their calculator saying DRG? Hit it for me. What mode is it in? Is it in degrees, radians, or that weird gradient thing? It's in degrees? Looks like a dog with this thing hanging off my ear. Where have you seen 2 pi before? Is that degrees or is it radians? That's radians. You're going to have to manually change your calculator to radian mode. Now remember where that key is. Does anybody have any trouble finding that? Like, there are different variations on calculators. I need to switch mine over to radian mode. Just did. Okay. Once you have it in radian mode, by the way, if you have it in degree mode, you will get the wrong answer. Sometimes spectacularly wrong answer. So this, I want to type in, but when you get to X, don't type X, type 20.75. Go ahead and type it in. Take a minute or so, 2.10. You can do 2.1 if you want. Cosine, 2. Does everybody know where to find pi? It should be an actual separate key on the right-hand side if you have a TI calculator. Okay, 2 pi. When you do divide, fraction, just hit divide. 2 pi divided by 21. Then open new parentheses. Just don't type X, by the way. Type 20.75 minus 13.75. Friend plus 4.78. I'm curious. It's actually a relatively nice number. Yeah, what do you get?
I got 3.73.
You are correct. It is unusual to have that few decimals. You got super duper lucky. We got y is approximately, so in other words, when x is 20.75, y is approximately 3.73. 3.73 what? What units? What do we imagine it go? Feet. That's the height of the tide at 8:45 p.m. on May 17th, 2021. Congratulations, you just did tide right. Now, did anybody not get that number? Okay, let me check the. Oh, merciful heaven. Yes. You might want to. They all out. There's one more. You might want to borrow one from me. This is easiest if you have what's called a 2-line display. The 1-line display, it's possible that it. I do actually have another borrow a graphing calculator from you, by any chance? It looks like somebody borrowed my spare. Okay. Yowza. Tell you what, I will give you my calculator for a second. Hang on a second. Okay, we're gonna take about 30 more seconds, and we're gonna check and see if everybody got that answer. 3.73 exactly. Did anybody not? Raise your hand now, so I can come to your rescue. Okay. Go ahead and type it in. Yeah. Okay. Anybody else still working on it? Okay. If you want to know what this looks like on a display calculator, it should look like this. 2.10 COS friend 2 pi. I need to be able to hear it. 2 pi, hit the divide sign, 21, open new parentheses, 20.25 minus 13.75, close parentheses, plus 4.78. That's what it should look like on your screen. If there are any of those keys you don't know where to find, especially pi, let me know now. Okay. What you got? Excellent. What'd you get? Interesting. How do I? Pi over 21. New principal. That's better.
I know.
Anything else? Yeah. Oh, so wait.
I knew you were gonna ask, so we're doing it higher.
Okay, the most common things are a misplaced parentheses, or if you forget a plus sign or a minus sign. If you forget a plus or minus sign, it multiplies instead, and it makes the answer really strange. Yeah. Pretty good type, yeah. Is everybody feeling semi-confident of being able to type that in? All right, let me hand this thing out. This is your assignment for tomorrow. Did we not get one of these? And Randy, I'll email this to you. Okay, a couple things to point out. Everybody take your worksheet out? Gentlemen, on floor. Look at page 1. They give you a bunch of data for number 1. You're going to use that data for all 5 questions. There are questions 3, 4, and 5 on the back. For now, number 1, it says sketch a reasonable graph like this. So this would be the answer for number 1. Number 2, identify at least 2 start points. What I mean is something comma something. This would be 3.25 comma 2.68. Don't use the time of day because computers don't understand that. Does that make sense? So the negative cosine start point, 3.25 comma 2.68. This one would be 13.75 comma 6.88. That would be answers for number 2. Now I changed the numbers on this. So don't just copy and paste the answers. Ladies and gentlemen, I'd appreciate if you attend to what I'm saying. Number 3, find a valid equation. It should look like this. I would leave this as 2 pi over whatever. If you get 2 pi over some decimal, that's okay. The calculator's not going to care. Just leave it. You don't have to simplify it. Number 4, what will be the height of the tide at 7 p.m. on July 1st? Now it's a different day. Caution. Do I have to ask for a time of day on the same day? No. I could ask for, what is the height of the tide, 12 noon, May 19th? That means you might have to, if you skip an entire day, how many hours do you have? 24, right. If you skip 2 days, you add 48, so on. When these get really involved, what I will do is I might say, you notice how this thing started May 17th? I might say, find the height of the tide to 4 decimal places for June 23rd, 2022. Awesome. Let me show you what that would involve. Pretend I'm going for June 23rd, 2022. Down here. That's over a year in the future. You need to convert that to hours. It's going to be a big number. It's not that hard, it's just tedious. How many days in a year? A typical year? 365, unless it's a leap year. You will have to pay attention to whether it's a leap year or not. In 2022 it is not. Only multiples of 4 are leap years. Now, if you have 365 days, how many hours is that? How do you find out? Yeah. 365 times 24. You get that number and put it off to the side. Then take the number of hours into the day. Everybody clear on that? If I have you go a year into the future, you take 365 days times 24. That's going to be a huge number of hours. Set it off to the side. I need you to focus on what I'm saying, not on what other people are talking about. It's also getting a little loud, people can't hear me. Then, once you get that number, then how many extra days are there? If it's an extra month or so, you have to count, okay, does that month have 30 days, or does it have 31, or does it have 28? You may have to do that by hand. So let's say if it's the entire month of February, and it's 2021 or 2022, that's a normal 28-day month. You take 28 times 24. There's an extra cluster of hours. Then the actual day of, if it's 3 in the afternoon, that's 15 hours. Add 15 more. So you're going to have a huge value of x, but the calculator doesn't care. Just put that huge value of x here, and it should be able to calculate it just as well as if it were a small number. In case you're curious what kind of extra credit questions I could ask, I might ask, find the height of the tide, July 1st, 2038. That means you're going to have to go multiple years, finding out which year is a leap year and which year is not, adding an extra day if it's a leap year, and then multiplying it accordingly. Okay? I'm not going to do that to you on a regular test question. This is kind of a typical test question. I'll give you 2 questions like, what's the height of the tide sometime on the same day when it's relatively easy? And then probably in 2 days from now, like 9 p.m. on May 19th. I'll expect people to know how to do that. Okay? The rest of the hour is yours to pound away at this thing. That we do tomorrow. Call me if you get stuck. Otherwise, you are welcome to the video. And I got a reminder from Mr. Rochers and his Latin tutoring going on this, the last one of the year. So if you're involved in that, you're anointed to go over and help. Yeah. Sinusoidal, that means either sine or cosine. It's a generic word for a sine graph or cosine graph. Yeah, I don't know if I even told you that. Sorry. That's a technical term, yeah. On the second page, when it says sinusoidal graph, that means it's a generic term for sine or cosine graph. The graph that waves up and down, that's called sinusoidal. The word sinus is from the Latin meaning cavern, so it makes little caverns as you go up, down, up, down, up, down. Yeah, that's where that comes from. Oh, we're done with recording, Mark. Okay, well, Randy, hope you enjoyed our show. God willing, we'll see you soon. Bye.